All right, I think we're going to get started here. So I want to welcome everybody to the Future of Whales and Seabirds. I'm Heather Gately. I'm the Director of Media and Communications for the Nature Conservancy in California. And I'm here with two Associate Directors of the California Oceans Program, Kate Cower, who leads our Sustainable Fisheries Strategy, and Nick Holmes, who leads our Island Resilience Strategy. And they're going to talk to us about the future of whales and seabirds. Now, I know many of you are already familiar with the Nature Conservancy, or TNC, as we say in shorthand, but just to provide some background, um, TNC is a global organization, a global conservation organization working for over 70 years to conserve the lands and water on which all life depends. We are science-led, and we employ over 4,000 multidisciplinary conservation professionals, including over 900 scientists, working in 79 countries around the world. To date, TNC has helped protect over 280 million square miles of ocean and more than 125 million acres of land. And that's just part of what we do. We have a vision for California where nature is abundant and resilient in a rapidly changing world. California is actually key to the Nature Conservancy's success globally. We have the world's fifth largest economy, conservation aware voters, and an innovation culture that has driven world changing advances in technology. And these factors create extraordinary enabling conditions for conservation breakthroughs, some of which you're going to hear about today. Kate and Nick are going to be talking about whales and seabirds, two incredible migratory species who depend on healthy oceans and lands in California to survive, but whose ranges extend far, far beyond our state's borders. So it's imperative that the work that their teams do protects these species across the entirety of their migrations, not just when they're passing by California. And that's a big goal. The threats to ocean health are daunting, from global climate change and warming oceans to the overharvest of marine species to accelerating pollution and habitat destruction. Globally, we've lost in total about 1/3 of some of our most important marine and coastal habitats already, and scientists estimate that we could lose more than half of the world's marine species over the next century. The oceans team here has worked to identify and understand the shared challenges in scaled ocean recovery, both at home and globally. They try to address the common barriers to ocean health that are relevant in all geographies, while being aware of the diverse contexts in which our conservation solutions must be deployed. Our ocean team operates as an essential innovation engine for global conservation. We think of it as an R&D shop, thoughtfully designing and testing and refining solutions to some of the planet's most urgent problems. Then we demonstrate the benefits and value of these new solutions in place-based projects, some of which you'll hear about today. Finally, we work to scale the solution we built in the most strategic and effective way possible. That can be TNC replicating that solution across the more countries that we work in. It can be working to ensure aligned partners are equipped to deploy that solution in their work, or it can be shifting state, federal, or international policy frameworks or markets to accelerate the transition to this improved approach. Another absolutely essential part of our recipe for ocean conservation is partnerships. TNC is part of a conservation community that extends around the world, and we believe we occupy an important and unique space within this community because of things like our global reach, our ability to leverage our preserves as living laboratories. But without partnerships, we would never be able to achieve the ambitious but necessary goals we have for our planet. What you're about to hear from Nick and Kate is the result of working with many different partners. And while we can't mention them all today, we'd like to extend a deep note of gratitude for all of the people and organizations who have supported this work. When we succeed together, our conservation solutions make a huge difference around the globe. And they need to, because as you're about to hear, in order to have healthy oceans here in California, we need to restore abundance across the Pacific Ocean. So before we dive in, Kate and Nick are going to present two options for what the future of the Pacific Ocean might look like. Nick is going to show you what could happen if we scale up our conservation work and invest in healthy oceans. And Kate is going to show you the future we might have if we let our oceans decline. So Nick, please take us into a hopeful vision for the future.
Well, thank you, Heather, and hello, everyone, and welcome. I'm excited to take you into a bright future for California, where the work of our conservation community has been successful. And what I'd like you to do is to imagine it's the year 2050, and you are a marine biologist, and you're traveling on a research vessel in Southern California, not far from the Channel Islands. And in front of you, a flurry of activity begins to take shape, thrashing and agitating the surface of the water. What you're watching is a bait ball anchovies coming together into a tight spherical space as a predator defense mechanism. And the air above you is filled with thousands of seabirds, and they are wheeling and diving into the midst of this anchovy frenzy. And you can recognize more than a dozen different species of pelicans, shearwaters, albatrosses, cormorants, murres, and merlets, all calling and propelling themselves with webbed feet towards a calorie-rich anchovy meal. And these birds are familiar friends. They're local species like the ashy storm petrel, it's about the size of an apple, and migrants from Mexico, Chile, and New Zealand that come to spend their winters in the California current abundance and get fat, like the pink-footed, the Christmas, and the sooty shearwaters. It's a digestive feast and a visual one too. It's marvelous chaos as the feathered thousands fill your field of view. And that's when the first whale appears. A loud geyser bursts from a nearby whale blowhole, and the mist passes right over your face, leaving you with a very fishy assault on your senses. It's a humpback whale, told by its knobby head and white-tipped flippers, migrating from Alaska to Mexico. And soon more appear, and they all begin to feed, rushing up at the anchovies from below, and their overwhelming mass breaching out of the water with mouths wide open in a coordinated attack on the anchovies. And as the whales burst into the air and the seabirds dive from above, you can really see a true marvel of our world and how powerfully interconnected these ecosystems are, moving above and below the waves. And for these species, the anchovies, the whales, the seabirds, and many others, to be present in healthy numbers in 2050, this means that there was a coordinated effort amongst conservationists, fishermen, people in the shipping industry, policymakers, and people like you that have succeeded in creating global protections and abundance across the Pacific that you can literally hear and see and smell and experience all around you. That's the future that we're working towards at the Nature Conservancy, and we're laying the groundwork for it today.
Thank you, Nick. I have to say that made me want to get out onto the ocean. And I'll mention that it's December now, and so it's a great time to see migrating gray whales pass off of California. So if you got the opportunity, definitely encourage you getting out to the coast with a pair of binoculars or even booking a trip to go whale watching. Nick painted this really vivid picture for us, but there really is nothing like getting out on the water and experiencing it all up close. But now I have the unpleasant task of taking us into imagining what it might be like in 2050 where people have left all. So the frightening reality is that instead of creating a future of abundance, it is possible that people might turn to a future of further exploitation of the ocean. We could increase drilling for oil and deep sea mining. We could end up overfishing a bunch of species that people and wildlife rely on for food. We could cause ecosystem-wide impacts, lost food sources, lost jobs, lost revenues. In this future, invasive species have taken over islands and atolls across the Pacific, and what were once hundreds of singular island paradises now look like the mainland with rats and cats and grazing herbivores. And all that unique flora and fauna that existed on these islands is vanishing quickly. And with that, we're also losing healthy coral ecosystems that support so many important marine species. And so when you're out on your research vessel in this version of 2050, whale populations have declined by more than a third, and you're lucky if you see just one migrating whale. The seabird species like the ashy storm petrel and the pink-footed shearwater are nearly completely absent now, and it's unclear if they actually still exist here. The wind smells salty, and that's it, except for the faint scent of oil from a nearby rig. The waves are rocking in a steady rhythm, and it's undisturbed because there's no wildlife breaking through the ocean surface here. Above all, it's really quiet above and below the water, and what you feel is an absence, loss of all that rich and vivid, unique species that make the oceans one of the most dynamic and biodiverse ecosystems on Earth.
So thank you both for taking us into the future. It can be really hard to think about how bad things could get for our planet, but I think it's worth it to remember that we have the science and the tools that we need to ensure that that isn't how our future turns out. So Kate, let's start with you as we focus on the good news and what TNC and our partners are doing to protect whales here and around the world.
Thank you, Heather. I'm also excited to get into the good news. So let's do it. And let's start with talking about whales. So whales, they're magnificent. They are awe-inspiring animals, and they are essential to ocean health, and they even impact our climate. Whales are what we call ecosystem engineers. They help maintain food web balance, and they support nutrient cycling through all of their feeding and migration patterns. And whale migration in itself is really remarkable. Some species like gray whales and humpback whales travel more than 10,000 miles between their feeding and their breeding grounds each year. And where whales are present, they end up bringing nutrients up to the surface, and they drive all of this growth of phytoplankton, which is the base of the ocean food chain. And phytoplankton produce a significant portion of the world's oxygen. And then whales themselves are also really important stores of carbon. And when they die and sink to the bottom of the ocean, they can sequester more carbon than mature trees. So while whales are really pivotal to ocean health, their populations today are only at a fraction of their past numbers. Commercial whaling began back in the 11th century, and it grew over time to meet the demand for whale oil. And so by the 19th century, we had thousands of whaling ships that had eliminated nearly 2/3 of all of the world's whales. And while commercial whaling has nearly completely stopped starting in 1986, many of the whale populations today have not recovered. So more than 85% of whale species are still endangered or threatened or of unknown status. And so even though we've largely stopped hunting whales, human activities are the leading causes of whale mortality. And currently, the two primary threats that humans pose are first, the accidental entanglement in fishing gear, like ropes and buoys, and then second, ship strikes from large, fast-moving vessels. So I'm going to share a little bit about these two challenges and what our team here at the Nature Conservancy is doing to make the ocean safer for whales here and around the world. So first, we're going to dive in and talk a little bit more about the problem of entanglements. So when whales get tangled up in fishing gear, they can haul it for hundreds of miles as they migrate. And all of that weight and additional drag can make it really difficult for them to surface, to breathe, to feed, to move. And over time, all the lines that get wrapped around their fins and their flukes can cause really severe injuries and result in death. And in California, many entanglements have been linked to the Dungeness crab fishery, which is one of the largest and most valuable fisheries on the US West Coast. The problem here isn't new, but it does appear that climate change is making it worse, as we've got warmer water, bringing forage species closer to shore and right into crab fishing grounds. So in 2015, we recognized there was an entanglement crisis happening off the coast of California, and we wanted to help solve it. If you look at this graph, prior to 2014, there was an average of about 3 to 5, up to 10 observed entanglements each year. But in 2015, that shot up to over 50 entanglements. And in 2016, there were nearly 60, which was the highest on record. And so our team launched a focused effort to try to help solve this problem. And from the start, we had two key objectives. The first was reducing the risk of whale entanglements happening in the first place. And the second was improving outcomes for entangled whales. So in this response to the spike in entanglements we saw, state managers here in California convened a meeting in 2015 to discuss the problem. And in that meeting, it became clear that there was almost no information. We had no records on where more than 200,000 commercial and recreational crab pots were being set over the course of the season. No information on how fishing activity and fishing gear moves around the ocean throughout the year, and no timely data on recent changes to the movements and the timing of whale migration. And so we all knew that without that information and without an understanding of what was driving the increase in entanglements, it would be nearly impossible to try to solve this problem. And so we got to work, but we knew that we couldn't do this alone, of course. And so we worked with the Department of Fish and Wildlife in California and the Ocean Protection Council, and we helped launch a first of its kind collaborative working group. And that included fishermen, state and federal managers, whale researchers, and other fellow conservation groups. And the goal was to understand the increase in entanglements and develop effective solutions. And so that working group started new research and developed new data streams that were tracking fishing activity, monitoring whale migration, especially doing that in remote parts of the coast. And all those new information streams were allowing us to create the first ever adaptive risk management tool to understand how entanglement risks change and then take real-time steps to try to reduce that risk. So, for example, we might delay the start of the fishing season or close areas with high whale activity. And this working group meets before and during every season to evaluate information on entanglement risk, latest scientific research, and then make recommendations for measures to keep whales safe. And so just this morning, I was in a meeting with this working group, and we supported delaying the Dungeness crab fishery another few weeks because of the presence of humpback whales. And so this risk mitigation approach is now codified in California law. And thanks to TNC and partners, this is now the new way of doing business for the fishery. And it's also serving as a model for how fisheries on the West Coast and worldwide can better protect whales from entanglement. Another way we work to reduce entanglements is minimizing the fishing gear that's left in the ocean at the end of a fishing season. So every year in the Dungeness crab fishery, we have about 170,000 crab pots that are put in the water. And these are big steel traps. They sit on the seabed, and they're connected to the surface with buoys and strong lines. And so up to about 10% of these pots might be lost each season just due to storms and passing boats. And that leaves thousands of crab pots and lines in the way of migrating whales. And since crab pots are expensive, they cost about $350 each. Fishermen are motivated to recover them, and that allowed us to envision a different solution to recovering lost gear. So we ended up providing seed funding for several fishing associations here in California to launch a pilot recovery project that aimed to create really a port-driven, self-funded model for lost gear recovery along the coast. And so to make this new model work, we increased the efficiency and eliminated wasted time looking for lost gear on the water. And we employed two approaches to do that are really integral to the whole oceans team's success here. One, we turned to the latest technological innovations, and we partnered with the people closest to the water, which are fishermen. And so we ended up building a software tool that collects location information for lost pots that uses geotagged images that fishermen submit. And then port coordinators on land use that data, and they plan more efficient recovery trips that are done by local fishermen. And so the software tracks each pot back to its original owner, who's then charged a fee for the recovery. And those funds cover port coordinators and the operational costs of recovery. So that model now has helped recover thousands of lost pots across California, leading to state regulations that codified the approach. And we're right now working to try to expand this recovery program by making that reporting technology more accessible to additional users. So last year we saw 27 confirmed entanglements off the West Coast, and this year we're up to 34. And those numbers are lower than our crisis years of 2015 and 2016, which shows that our collective efforts are improving outcomes for whales, but unfortunately, accidental entanglements are going to continue while there is some fishing gear in the water. And that's why it's really essential for us to also improve our response to helping those entangled whales. So around the country, there are trained volunteer disentanglers like those on this Zodiac here, and they work with NOAA, and they're deployed in response to an observed entangled whale. And we saw two key ways to improve the efficiency of this process too. First, we wanted to expand the number of trained responders. So we worked with NOAA, and we created the first ever online training for recreational and commercial fishermen, whale watch companies, and other folks, even you and I, to identify, document, and then initiate responses to entanglements. So over 1,000 people now have completed this course, which increases the ability to actually get out to these entangled whales. Second, we looked at upgrading the tracking tool that's used to help locate and track entangled whales. So as you can imagine, it can be pretty hard for these highly trained responders to go out and untangle a 40-ton whale in just one go. And in those cases, what the team will do is attach a tracker to the entangled gear on the whale so that that whale can be found again and completely freed. And so previously, the standard tracking device was pretty heavy at about 45 pounds. You can see it here in white on the right. And that tracker created a lot of drag, and it used some outdated tracking systems. And so we worked with NOAA and 2 design firms to begin redesigning this tool. And the new device that we've created is called Scout, and it's 10% smaller, it's 25% lighter, it has 35 times less drag, and it also features improved satellite tracking technology, which sends more detailed GPS data to responders. And so we've got 2 of these units out now being tested by NOAA disentanglement teams here on the West Coast. And we've got a plan in place to try to distribute at least 10 of those units to teams all along the West Coast and Hawaii in the coming year. And our goal is to eventually get 50 to 100 of these units manufactured and into the hands of disentanglement teams all around the world. So now I want to delve into the other major human-caused threat to whales, which is the global shipping industry. So this industry consists of about 50,000 commercial cargo ships and transport 90% of the world's goods. And these large ships travel at very high speeds across every major ocean. And whales did not evolve to be aware of this danger, and they are definitely not equipped to avoid it. We recently collaborated with dozens of researchers on a new study that found that shipping routes overlap with 92% of whales' ranges, showing here in the red are those high points of overlap. And that makes ship collisions a major cause of whale mortality globally. Here on the West Coast, 2018, 2019, 2021 were some of the worst years we've seen for ship strikes to whales. But the study that we did also highlighted a path for progress. So right now, less than 7% of those hotspot areas have management strategies in place to try to reduce collisions. So by adding protections in less than 3% of the ocean surface, we could really significantly reduce the threat of whale mortality from vessel strikes. And there's more good news on this front. New technology developments can really help us solve this issue. So we know that sufficiently lowering vessel speeds in areas where many whales are can help reduce mortality risk by up to 90%, essentially just giving whales a little bit more time to get out of the way. And the challenge is knowing where whales are to deploy those speed reduction efforts really efficiently. And so our team set out to demonstrate how technology could help fill some critical data gaps we have on whale migration. We partnered with researchers in Spain to develop machine learning algorithms that can detect humpback and gray whales in high-resolution satellite images. So in other words, we can now use AI to locate whales from space. And we just launched a new platform, which is whalesai.org, and it's bringing this solution, this tool, to managers' fingertips. So right now we're partnering with NOAA's Office of the National Marine Sanctuaries to pilot this platform for their vessel speed reduction program in the Santa Barbara Channel. And specifically, what we're aiming to do is provide them with better information on when to start and end that program so that we minimize disruptions and costs to the shipping industry and reduce whale strikes. So this is just the first use case, and we're envisioning many other uses of this tool to protect whales, especially in remote settings where there's really little or no monitoring of whale migration. So I'm really thrilled to be able to talk to you about all of this work, and especially about this Whales AI platform, because this is hot off the press and is a big step forward for our ability to protect whales. We know what we need to do to effectively reduce whale strike mortalities, and of course, creating all of the global awareness and buy-in and political will to implement those changes is going to take a lot of effort from a lot of folks. But here at TNC, we're committed to being part of that change, and I'm hoping that you'll be a part of it too. And so I'm excited to hand this over to Nick, and he's going to cover the Seabirds portion of our Whales and Seabird webinar.
Well, thank you, Kate. It's incredible work being done, and it's exciting to be here with you. So yeah, my name is Nick, and I've been fortunate to work in the island restoration space for a couple of decades now, and been very fortunate to work in places like Australia, the Antarctic, Hawaii, and now I'm really enjoying time in California. And birds, especially seabirds, are really interwoven into the ecology of islands, and they offer great insight into sort of the urgency and the opportunity that we have for island restoration. And on the screen in front of you is a personal favorite of mine. These are king penguin chicks. These are marvelous beasts, and if you ever have the chance to meet one, I highly recommend it. So my role at TNC is to strengthen and scale conservation on Pacific Islands. And TNC owns many important island preserves. And now they have an island resilience strategy with a goal of scaling lessons learned across the Pacific. And this is what I lead along with my colleague, Dr. Alex Wegman, here on the screen. And today, after a little bit of Seabirds and Islands 101, I wanted to show you a bit more about how we work, including local action that demonstrates what can be done, how we leverage science to think about scaling, and how we're being both innovative and brave in the conservation space. So why islands? Well, if you put all the islands on our planet into a bucket, it totals only about 5% of our land mass. Yet on that small percentage, we see nearly 20% of all bird diversity and many other guilds as well. Islands have also hosted a greater number of threatened and extinct species per unit area than continents. And it's this confluence of high conservation need in a very limited land area that make islands a global conservation priority and an opportunity. And seabirds, like this albatross on your screen here, are ambassadors not just of islands, but of oceans as well. Most seabirds forage only at sea, and their body shapes and their behavior have evolved to travel far or dive deep, ultimately in search of food. But seabirds also need land to breed, and most seabirds have evolved to raise their young on islands, safe from harmful predators. It's worth pointing out that seabirds are really important to many human cultures around the world too. They are some of the original navigation aids alongside the stars, and they are indicators of fishing opportunity, just like our bait balls earlier. We're also learning a great deal that seabirds are ecosystem engineers, just like our whales. On islands, they can play key ecological roles, meaning that if we can restore seabirds, we can also spur the protection of whole ecosystems and all the benefits those places provide to both people and nature. For example, on tropical atolls across the Indian and Pacific Oceans, we're learning that seabird poop, seabird guano, is very important for healthy coral reef functioning. By feeding only at sea, these seabirds are gathering marine nutrients in the fish and the squid that they eat. And then they transfer these back to these small atolls where the seabirds are breeding or roosting. The nutrients then become an invaluable part of that local nutrient cycle that extends all the way into the coral reef. And we're seeing positive impacts on things like fish populations and even reef capacity to grow and sustain itself. On islands, invasive species are a foundational threat. Recall, invasive species are non-native that cause environmental harm. And many island species evolved in the absence of mammalian predators or mammalian herbivores. So when species like cats, rats, or pigs were introduced to islands, sometimes accidentally, sometimes deliberately, native species often had no natural defenses and suffered devastating impacts. On your screen are images from Laysan Island, which is in the Northwest Hawaiian Islands, or the Papahana-Makuakea National Marine Monument. On the left is before humans settled, and on the right is after. Humans were there after albatross eggs and seabird feathers for the haberdashery industry. And when they came, they also introduced the humble rabbit as a food source, which in turn devastated the local plant life. 3 land bird species, known only from this one island, went extinct in that very short time, simply because they lost their habitat. And of course, massive numbers of seabirds abandoned the island as well. But it's not all doom and gloom. There is hope. You can do things on islands that are simply not possible on the mainland. It's one of the reasons why many of us work in this space. In the Channel Islands of California, harmful populations of invasive mammals have been removed multiple times. On the left is Anacapa Island, where the Channel Islands National Park and NGOs like Island Conservation successfully eliminated rats more than 20 years ago. And because of that action, seabirds like the Scripps' mulet, which you can see here on the screen, were freed from unnatural predation and they have bounced back in record numbers. And it's not just the seabirds that benefit. On the right is Santa Cruz Island, where TNC and the park removed non-native sheep and then pigs. And the vegetation recovery has been astounding. And very excitingly, this contributed to the delisting of 2 very rare plants from the US Endangered Species Act earlier this year. Another key activity that we engage in is science to promote opportunity for scaling. For example, there's many more islands where harmful invasive species do continue to occur. When it comes to rats, for example, it's been estimated that maybe 80% of the world's island groups continue to have rats. So what we did and what you're looking at on your screen is we collated similar examples of where harmful invasive mammals have been removed from islands. And it turns out that's been done more than 1,000 times with a success rate of about 85%. We've published these results and they've become a really powerful tool for demonstrating that these actions are indeed scalable and applicable to many more islands around the world. But the job doesn't stop there. For those fortunate islands that don't have harmful invasive species, like Anacapa and Santa Cruz Island, a key action is preventing them from coming back and getting established on the islands again. This is especially true for species like rats. They can easily become accidental hitchhikers on boats, and if they reach islands, they can breed up very, very quickly to harmful levels. So to help us protect islands, we needed a new tool to quickly detect any potential arrivals and alert managers so they can respond quickly before it becomes too late. So we turned to TNC's conservation technology team for a solution, and they identified a great way to leverage machine learning and wireless camera trap networks. And what's on your screen is what it kind of looks like. The solution is called Animal. It's a free open source cloud-based software platform that when it's connected to a wireless trap network allows managers to quickly make sense of camera trap data. On the screen is what it looks like for islands, and you can see the tool acts more or less like a ring or a Nest doorbell for the island, whereby managers now get an alert of an unwanted guest. Our testbed for developing Animal was on Santa Cruz Island, and we've been working with partners in Hawaii to pilot deployment in specially fenced areas, islands within islands, to protect seabird populations from pigs and cats. And it turns out it's working pretty well. But sometimes we need to do more to bring seabirds back. And on the screen is Palmyra Atoll. This is a TNC preserve inside a national wildlife refuge, inside a national marine monument, and what we call a conservation turducken. Now, invasive rats were accidentally introduced to Palmyra back in World War II, wiping out up to 8 species of seabirds. Now, rats were eradicated in 2011, but these seabird species weren't returning on their own. Perhaps they lost the generational memory of Palmyra. So we needed to do something more to help them return. And our approach is quite simple. We give the birds a reason. And what better reason is there than sex? So we use decoys arranged to look like real birds nestling together on the ground, and we play mating calls over loudspeaker systems called Seabird discotheques. We started this effort about 3 years ago, and already one species, the greyback tern, of which the decoy is pictured here on the screen, has returned and successfully raised young 2 years in a row. And we've got a second species turning up that really seems to enjoy the pillow talk. We're really optimistic about our plan to restore Palmyra's seabird community. And as I mentioned before, when those birds come back, they're going to help restore the full suite of nutrients that help support the atoll and the coral reefs as well. So climate change is another key threat to seabirds, and it may lead to the loss of breeding habitat on many islands. To overcome this threat, new and more creative thinking is being tested in the conservation space, including, can we move species to new homes? And that's exactly what we've been trying to understand for two species on your screen, the laysan and the black-footed albatross. Both rely on low elevation Midway Atoll to safely breed, but the projected storm intensity will increase on Midway, and it's going to put the island and safe nesting habitat at risk. There's a lot of effort going into restoring past colonies on high elevation main Hawaiian Islands and back to Guadalupe Island in Mexico, here in the California Current. About a decade ago, a question was asked about the California Channel Islands. Could they also be a suitable island for albatrosses right next to one of their major feeding grounds? It's certainly technically possible using a strategy called chick translocation. Now, albatrosses are very, very site faithful when it comes to breeding. When the chicks fledge from a location, somehow they know to return to that same island. And this is a behavior that we can manipulate. By moving chicks to a new home before they take dislocation fix, we can help them imprint on new sites. But it's not really clear if albatrosses ever bred in the Channel Islands. So for the past couple of years, we've been working with partners like Pacific Rim Conservation to explore exactly that risk. Would this be a harmful thing to do? And where would you do it? And so far, places like Fox-free Santa Barbara Island seem to offer reasonable propositions. This is just an idea so far, but that's how all great conservation starts. We mustn't be afraid to try new things, especially as we face the environmental challenges of the future. So there you have it. What I've shown you today is a snapshot of how we work through the eye of a seabird. And conservation like this takes enormous effort from many dedicated partners. And at TNC, we're really committed to being a part of that charge. And I hope that you will too.
Thank you so much, Nick and Kate. Once again, I just want to take a moment to acknowledge the many organizations and individuals who are part of the successes that we've heard about today. And that includes many of you. So TNC depends on our incredible community of members and supporters, including many of you on this call. So for the last portion of our webinar, we're going to hear from you in our Q&A section. Please click on the Q&A function to submit any questions if you haven't already. I will let you know that we've had a lot of Q&A questions submitted, and I don't know if we're going to have time to get to them all. So we're going to do our best to answer the ones that we can. So just want to thank you for your questions. So one of the questions that came up, and I think this might be for you, Kate, and I'm not sure if you're familiar with this, but I've heard that krill and perhaps other food for whales, seabirds, and others are declining worldwide. Is that true? And what is being done, if anything, to reverse this?
That is true. We have seen changes in important prey species for whale, including both anchovies, sardines, and krill. I think there has been a lot of research in the Antarctic Ocean on krill and seeing declines in krill abundance due to climate change from warming waters. And that's concerning because krill is a base of the food chain and really important for whales and lots of other species. And so things that are being done to address that have to do with addressing climate change, conservation, and reducing other threats to species that rely on krill. What's interesting here off the West Coast, we've seen changes from climate impacts to other forage species, sardines and anchovies, and humpback whales in particular are adaptable, so they will switch up their feeding strategies depending on what is here. But part of the challenge that helped drive that crisis of entanglements on the West Coast was related to a shift where prey species were on the West Coast, and the timing and the spatial extent of the prey species put them in the path of fishing grounds and it led to more entanglements. So In that case, also looking at climate change being a major driver of those important prey species. And we're also seeing similar impacts to other benthic species like amphipods that gray whales feed on, having impacts up in Alaska, in the Bering Sea on those species as well.
Thanks, Kate. This might be a kind of a good follow-up to this to a related question. So one question is, did records of entanglements show an increase in the 2015-16 because of better observations and record keeping, or an actual increase in entanglements?
We think that that large increase is really driven by a true increase in entanglements, and that was driven by sort of a perfect storm that we had that year, where there was a harmful algal bloom of a species called Pseudonychia, creates domoic acid that bioaccumulates into species like crab. And we do public health monitoring of crab to make sure that we're not putting that on people's tables when it has domoic acid in it. That meant we had a delay in the opening of the Dungeness crab fishery. And once it did open, after that domoic acid had passed through, it was peak migration season. And that is likely what caused that very significant increase. In addition to having prey species for whales being pressed in closer to shore, because we had had a large marine heat wave prior to those years that had shifted where prey species were. So we think that's really what drove that very significant spike. But there is thinking that we do have more eyes on the water now, and we are better at reporting the amount of entanglements that are out there. So that may also be driving the increase in entanglements. And then the last thing that has been interesting is that the humpback whale population off of California, one of the lead researchers out here has shared that we think there might have been as much of a 10% population increase in whales, so almost a doubling in their numbers off of California. So we're seeing more whales here off the coast. And at the same time, we're seeing sort of an increase in entanglements that may also be driving the pattern that we're seeing. But it is a combination of effects for sure.
Got it. Awesome. Thank you. This one I think is more for Nick. It says, you mentioned Hawaii, but what's happening with the mosquitoes and avian malaria? I'm not sure if that may have been a submitted question.
Yeah, I'd be happy to talk about it. This is quite a remarkable story. And again, it deals with one of the most harmful animals on our planet, the mosquito. And in Hawaii, not only was there no native mammals as a part of the evolutionary history of that location, with the exception of bats and seals, there was never any mosquitoes either. And so the birds in that location in Hawaii evolved without mosquitoes. And what that also meant is they evolved without a mosquito-borne disease, avian malaria. And mosquitoes that do occur here in the mainland, where avian malaria also occurs, we find that the birds have a degree of immunity. They've evolved with that disease. But when mosquitoes were introduced to Hawaii many years ago, primarily after whalers and then missionaries became established in Hawaii, we also saw avian malaria introduced to Hawaii. And there's a suite of birds, about the Hawaiian honeycreepers, of which there used to be about 50. Avian malaria was a major factor contributing to the loss of nearly 30 odd of those species. And what we're dealing with today is the remaining Hawaiian honeycreepers at high elevation rainforest areas, basically where it's too cold for mosquitoes. But climate change is pushing that envelope further uphill. And what we're finding is that these tiny little rings of refuges around the Big Island and Maui and Kauai are eventually going to get flooded by mosquitoes, and these birds will be more vulnerable. And TNC is part of a major group called Birds Not Mosquitoes, which involves many NGOs and government partners to try and solve for that solution. So we've been testing a mosquito suppression tool that's actually based on an innovative solution in the human health industry. It's called incompatible insect technique. And it's basically a big test to see if we can do this. But it is one of the conservation moonshots of our decade to see if we can solve for avian malaria in Hawaii. So we have reason to be optimistic, and I encourage you to watch this space because it is a really remarkable story. It's a harrowing story, but it's also got a reason to be hopeful. Great question.
Here's another bird one. Our city, this is pretty specific. Our city Shearwater is the longest of migrations at 31,000 miles. Do you know that,
Well,
Nick?
it's very long. So Sooty Shearwaters are awesome for so many reasons. They breed in Australia and New Zealand. I'm from Australia. You can hear my accent. And they're called the TT bird down there, and they're really, really important. They breed in hundreds of thousands on very small islands, and these birds have evolved to migrate up to the California Current and up into the Bering Strait, where they spend their winters, our summers feeding and getting fat. And when you see them at sea in the California Current off the coast there, they are just getting plump, plump, plump. It is an enormous migration, but it is not the longest. The longest is the Arctic tern, which goes from the Arctic down to the Antarctic. And it's a little bit further, and it is a surprisingly svelte and streamlined little bird to travel that distance. And it's gorgeous, very white, bright red beak, and it's got this harsh, piercing little cry as it flies overhead.
Awesome, thank you. I have one more bird question for you, and I'm going to apologize to the person who posted it because I'm going to probably murder the pronunciation, but here's my go. I was on an expedition to the Revillagigedo Islands off of Mexico, and there were some Laysan albatrosses there, and they seem to be colonizing Mexican islands recently. Will they colonize further north? Do you know that, Nick?
That's a great question. There is some Mexico, and particularly Mexican islands. There's some really remarkable conservation occurring, and there's a group there called Grupo de Ecología y Conservación de Islas, and they are working with the Mexican government and partners in Hawaii to strengthen the conservation of albatrosses. Now, on Clarion Island and on Guadalupe Island, there's historical records of Laysan and Blackfoot albatross breeding. But then they were gone. And that was due in part because of invasive predators on islands. The albatross and many other seabirds simply couldn't persist on those islands. A lot of those predators and those invasive mammals have now been removed, and the Laysan started to turn up on their own, but the Blackfoot had not. And so there was a concerted effort to try and bring the Blackfoot back to Guadalupe Island. And that was led by HESI, who I mentioned earlier, and Pacific Rim Conservation. And it turns out those birds actually do better than the Hawaiian birds because they are mainly feeding in the California Current. So they don't have as far to travel, and they spend less energy to get that food. And that's why we think there might be good reason to think about them eventually becoming a part of the Channel Islands as well, because it might be a better place for them to breed. Are they moving north? We are seeing a little bit more of that activity. And certainly we've seen species like boobies that are normally a tropical species turn up in the Channel Islands and even the Farallon Islands. So yes, we're beginning to see a little bit of that occurring.
Great, thank you. I have one for Kate. How do you see whale watching in relation to whale conservation?
Ooh, whale watching is, one, whale watching companies right now are a really important partner on the West Coast in terms of providing information, all those information streams we talked about for the Adaptive Risk Management Program. So they're critical, and they're real-time reporting the amount of whales that they're seeing and where they're seeing them. And that's getting sent in to state managers and to the collaborative working group that we're part of. So that's fantastic. I also think whale watching is a really important way to get average citizens engaged and interested and out on the water. And then a lot of those groups that are whale watching companies will either support conservation efforts in ways like partnering and delivering data, or even donating funds to marine conservation projects around the world. So we look towards our whale watching partners as really critical components to the whole ecosystem here, driving better outcomes for whales. So I think they are a really important part of the conservation picture.
Awesome. So this is for both of you. I love this question. So how did you get interested in your career, and what was your training? Who wants to go first?
You want me to go first, Nick? I'll hand it off to you. My interest stemmed from a childhood spent at the beach. I had parents that only took us to the Outer Banks in North Carolina for pretty much every vacation or time off of school that we could get. And we spent all of that time surfing. And if the surf wasn't good, we were fishing. And that spurred my interest in the space. And I did my undergrad in biology and worked with a marine biology professor. And then took that and made the trip across the coast here from the East Coast to the West Coast and did a master's of environmental science and management at the Bren School, UCSB, and focused there really on fishing and managing fishing, and was really interested in the intersection between people and nature and the ability to work on those critical problems and have conservation and great benefits at the same time. So that's how I got up and interested in this and landed here.
Very similar. A childhood spent outside that, and then poring over maps and field guides and realizing that there were pretty wild and wonderful places out there in the world, particularly islands. And I realized that it was important for me to get to those places. And part of the way, really the only way to do that as a young person, was to be a part of expeditions there, either as a student or as a ranger or something like this. And once I got to some of these wild and wonderful places, particularly down in the subantarctic and out into the Pacific, it very quickly became a story of learning about invasive species, learning about seabirds, and learning about restoration opportunity. What's really we can make change, positive change, in a relatively fast time spans. And so that led to study. I went to the University of Tasmania, and I fell in love with an American and have migrated myself towards California. And I really enjoy working at TNC because it's a very solution-oriented organization, and yeah, it has reach, and so it's a really meaningful place to work. And so I encourage you, I think, anybody out there, to get outside and find your passion and keep going, make a difference in this world.
Awesome. Thanks both. I have a question here. There's actually a couple questions sort of in the same realm, so I'm going to try to capture this. It seems like there's a third potential option of changing fishing gear so that entanglements either self-untangle, sorry, or break apart. Has new fishing gear like this have been investigated? And another one around crab pots being electronically raised and not needing ropes from the ocean floor to the surface. Is that something that we're pursuing?
Yeah, so TNC historically in the fisheries program, we've been very supportive of gear innovation work, and we've done lots of different projects on gear innovation to do things like reduce bycatch of vulnerable species in the swordfish fishery, reduce bycatch of overfished stocks in the groundfish fishery. And we see a really big importance first in just experimentation. So when we have conservation problems like entanglements, one of the best things we can do is partner with folks that are closest to the problem and trial out and experiment what might work to solve that. And one of the things that was lacking in California a couple of years ago was the ability to actually go and do that experimentation. And so TNC was instrumental in passing a bill in California in 2018 that was called the California Fisheries Innovation Act, and it set up something called an experimental permit. And that has created a pathway now where any interested fisherman, conservation group, university researchers, you name it, can apply for one of these permits to be exempted from current rules and test different types of gear or different types of methods of fishing or anything that might actually solve a challenge that you're facing in that particular fishery. And so this program now has been used extensively in the Dungeness crab fishery to test lots of different methods to reducing entanglements, which includes reducing the amount of vertical lines that we see in the water, as well as testing things like what we call pop-up or ropeless gear. And so right now there is active testing going on of this type of gear, and it is a really important component in driving the solution. The testing so far has all been fairly small scale. There are definitely challenges still right now with economic viability of the gear. The pop-up and the ropeless gear is expensive. It can cost upwards of $4,000 per pot, which is massive. And there is still a pretty high incidence of loss. So you're seeing, maybe only 90% of the tested units coming back up to the surface. So there's more to do, and there's more growth and opportunity to test out and develop these solutions. We think that's an important part of the problem for sure, and I think experimentation has to be what we're leading with to get to a better future for whales.
Thanks, Kate. I think we have time for 2 more questions. So this is one more for you, Nick. I've been following the translocation of the sea heck or Guam kingfisher to Palmyra. How are they doing?
Great question and super fun. And for those that aren't familiar with one of the coolest conservation stories occurring right now, I encourage you to Google the sea heck, and particularly follow the Sea Heck Recovery Project on Instagram. Long story short, sea heck for those not familiar, sea heck were nearly lost from our planet. They are known only from the island of Guam. When the brown tree snake was accidentally introduced to Guam from World War II, we lost a lot of birds, went extinct. Guam kingfisher were able to grab a handful of individuals, and in the late 1980s, and they were moved to a zoo mostly in Kansas, believe it or not. And then the long-term goal has been to get them back to Guam, but the conservation community, has not been able to solve the brown tree snake problem on Guam. They still persist. So a new challenge was created. We need to find a home, a temporary home, out in the wild for these birds until the brown tree snake problem can be solved. And Palmyra Atoll was chosen as that place. And earlier this year, with a really amazing team from Guam Department of Natural Resources, the London Zoological Society, this Kansas Zoo, the US Fish and Wildlife Service, and TNC, we brought the first 9 individuals of the Guam sea heck to Palmyra, and they were released only a couple of months ago, and they are doing awesome. They are enjoying their new home. This is the first time since the 1980s that the Guam kingfisher is now living in the wild. And so it's quite remarkable. And yeah, watch this space. They're happily foraging, and they're even beginning to show a little bit of behavior that indicates they're pairing up. So fantastic.
Awesome. They're such a beautiful bird too. They're one of the prettiest. So definitely follow them on Instagram. We're about at time, but I really do want to have one more question since we've had so many, and I think this is a good one, probably for both of you. So, why is it important for whales and seabirds to migrate, and what can the average citizen do to help support their journeys?
Well, I'll give you a quick one. So, animals that migrate, well, animals have a choice, particularly when it comes these polar organisms. They either get fat and stay where they are, or they move to find resources to survive the winter. And so when you think about these Antarctic seals, for example, they basically turn into giant slugs and overwinter in these places. Whereas birds leave, and they will go and look for the foraging opportunity. And because they are such efficient flyers and whales such efficient swimmers, they can cover the entire hemisphere of our planet. And so they're coming to places like the California current because it's so rich in marine productivity. That's how they've evolved to come here. And it's a story of wind, and it's a story of time. And how can we help that? Well, you're doing it right now. Become aware of these animals, go out and see them and develop a connection, and smell and hear and listen to them, and then make it a part of your life. Find out how you can make a positive difference in this world.
Anything to add, Kate?
I'll just add quickly. Nick covered it perfectly. Whales, same story. Migrate to get fat and feed, migrate to go breed and calve. Really important. We talked a little bit about the impact that whales have on the ocean ecosystem through their migration patterns and the nutrient pump that they create. So it's critical that these migrations continue. In terms of getting out there and doing things, you make choices with your pocketbook. You can always make smart conservation-friendly choices with purchases and seafood investments, those sorts of things. The other thing you can do, I'm going to put a quick link in the chat. Everybody can get trained as an entanglement responder now. And there is a section here on this link from NOAA that says what you can do to help. And so there's a hotline. If you see marine mammals that are stranded on the beach, they see an entangled whale, you can be part of the solution too.
Well, I just want to thank you both, and I want to thank all of you for joining us for the future of whales and seabirds. I would also invite you to check out Kate's links in the chat if you have any questions. So we'll see you next time. And if you could just take a moment to answer a survey question at the end of this webinar, that will help us understand future presentations and offerings. Thank you.